Okay, so we're going to continue with where we left off the other day. The last notes we took right here, fossils can help scientists determine the age of rocks, even when earth forces have caused the rock layers to become out of order. So we're going to continue with that. Here we talked about rock formations and earth forces, how the plates will rub against each other, pulling apart and pushing each other, and that the plates float on top of Earth's mantle. And remember, that mantle is made up of liquid rock. So here, in a cross-section under Earth's surface, the layers of rock that make up the crust are floating on top of the thick mantle of liquid rock. And earthquakes are just one example of earth forces caused by tectonic plate movement. They occur when the plates interact, typically when they are pushing together or sliding past each other. So when those plates interact with each other by pushing together or sliding past each other, earthquakes can occur. And here's some drawings of how tectonic plates can also cause rock layers to bend and fold. So you can see these layers are a little out of order based on how they have bent and folded. The colors aren't really matching up as well. Okay, and it can be trickier to understand what has happened in Earth's history when these rock layers get jumbled up. So that's when scientists use fossils and other clues to help them understand the ages of rocks, even when they're jumbled up. So here you see an example of the oldest layer up to the youngest layer, and these fossils help scientists discover and determine the age of these rock layers, even though they are now diagonal and they aren't in those nice horizontal straight lines like they usually are. We're going to skip over these questions and we're going to head on into tectonic plates. Tectonic plates. All right, so as we move into tectonic plates, I'm going to go ahead and give you all of the vocabulary I want you to write down. Plate tectonics, plates, tectonic plates, and that Earth's plates float on top of the mantle. Pause the video so you can write down those notes. And when you're ready, play it again. So this is an image that talks about tectonic plates. The crust is divided into two types. It's divided into oceanic and continental. So if you look closely at this map of tectonic plates, you can see that parts of the plates are covered with water and parts of the plates are covered with land. So we're going to write that down. All right. So if we look at the oceanic crust, it is made of dense rocks such as basalt, and this means that the oceanic crust is very heavy. So if this is the ocean floor, like where you would step on sand, the oceanic crust is about 3 levels down, and the oceanic crust is about 4 miles thick. So that little layer that it's showing us in that picture is really 4 miles thick. And then underneath, we've got the mantle. So it's made up of less dense crust, this continental crust. So remember, that's the crust where you would find land. And it's lighter than that oceanic crust. And its thickness varies between 6 to 47 miles. So it's thicker than the oceanic crust, but it's not as dense. The rock it's made up of is not as dense. Continental crust is almost always much older than oceanic crust. And there are 3 types of tectonic plate boundaries. There are convergent, divergent, and transform boundaries. So we're going to write that down. And if you look closely at this map of tectonic plate movement where you see these lines, you can see arrows showing that different plates move in different directions relative to each other. So here are your little arrows, okay, and these lines are showing you where those plates are using this map. So convergent boundaries are plates that collide with one another. They collide with one another. And this is where the continental crust is created and oceanic crust is destroyed as it subducts, melts, and becomes magma. Divergent boundaries are when the plates separate. And this is where geysers spurt superheated water and magma or molten rock rises from the mantle and solidifies to form new crust. So at divergent boundaries, oceanic crust is created. And then finally, we have transform boundaries. This is where plates slide past one another. And this is where earthquakes tend to occur. So when those plates move and rub up against one another, the new crust is neither created nor destroyed at these transform boundaries. This just causes that quake to happen. All right, and this is a diagram of these 3 types of plate boundaries. You can pause your video to take a good look at it. You've got convergent plate boundaries happening here, the transform plate boundaries, the divergent, and it's labeled with the different plate boundaries. So you can kind of see in real life what it would look like, as well as the layers underneath the Earth's crust. And we're going to pause the video here and continue on with this, starting with this image on our next day.